I want to talk about the general sinusoidal function. I thought I did. Okay. So here is a general sinusoidal function. And if you actually think about it, this is a lot like what we did in Chapter 5 with just general functions. And this represents all the different things you could do to the sine function. And I'm going to reiterate, everything we're going to do today, you could also do to the cosine function. And some people might even believe that you don't need the cosine function if you just shift the sine function left or right. You can always get a cosine function by shifting the sine function. So we're going to focus today mostly on the sine function, even though tonight there's going to be some questions about the cosine function. Okay? So we've talked about two of these letters, and then we're going to talk about the other two today. So what have we talked about, and what does it mean in terms of this? Heard from you. Mo.
A.
Yeah, what is A?
I mean, vertical shift or compression.
And I'm going to call it the vertical stretch or compression. So if you remember from Chapter 5, that's exactly what A is. We have a very special name for it in trigonometry. When we're talking about a sine or cosine function, what do we call A? Say it, Michelle, because I think you just said it.
No.
Oh, you didn't.
It's one of your fantasies where we all yell at you.
Yeah, pretty much. A.
Amplitude.
Yeah, it is. All right. All right. That's exactly what we call it for sine functions. That A, that vertical stretch or compression, is the amplitude. It's how high above or below we're going to oscillate between another term, which I'm not going to use because you're going to tell me. Danny? You said B? B is not the period. It's not the midline. It's close to the period. When we talked about B in terms of functions from Chapter 5, what did we say?
B was the horizontal.
It's the horizontal stretch or compression. All right. Now, it's not the period, but it is closely related to the period. As a matter of fact, if B is 1, what's the period of the function if B is 1? 2 pi. Okay? If B is 2, it actually makes everything happen twice as fast, so the period is pi. So here's the relationship. B is not the period, but B equals 2 pi over the period. Or, another way of writing this is to say the period equals 2 pi over B. Whoops. Okay, so if you know what the value of B is, then you can find out what the period is by doing 2 pi divided by B. If you know what the period is, you can find out what B is by doing Gesundheit, 2 pi divided by the period. So, just to reiterate, it's important because many students get this mixed up. B is not the period, but if you remember from Chapter 5, as Danny did, B is the horizontal shifter. B is the horizontal compression or stretch, and the period is based on B. So there's an important relationship between B and the period, and that's what that is. Okay. I think I should just say this. We always say the absolute value of A is the amplitude. And I don't think I've mentioned that before. If you have a -2 in front of the sine function, we wouldn't say the amplitude's -2. We say the amplitude is 2. The amplitude's always a positive number. As a matter of fact, what would happen if there was a negative in front of the A? What would that do to the function? Flip it.
It would start going down.
Over the x-axis, and when we shift it more, it's going to be over the midline when we talk about that. Now, we're not ready for that yet, though. Andrew, do you want to do a welcome back and tell me which one of these letters represents the midline?
Is it C?
No, try again.
D?
Awesome, very good. I knew you could get it on your second chance. All right. So D is the midline. In chapter 5, what would we have called D? Vertical shift. Okay, so the vertical shift is exactly what we... Oh my goodness. Sorry. It is. Is exactly what we call the midline. And then that leaves us with C. And we don't really have a special name for C. What does it do? It's the horizontal shift. Now, do you see how the B is factored out from the x minus C? Here's like a little side note. If you ever have a function that's a times sine of bx minus do you see how in this case I distributed the b to get some other value, which I'm calling bc right now?
Yeah.
Okay. If you ever have a function that looks like that, without the b factored out, but the b distributed in, we call bc something, it does have a special name, and it's called the phase shift. I'm going to be honest, we are going to be more concerned about the horizontal shift than the phase shift. But if you run across a question or a problem that asks about the phase shift is just when you distribute b in. It's that term b times c is called the phase shift. And I'll look into it. It's more, I think scientists use phase shift more often than mathematicians. Okay? And I'll do a little bit of work on that. I feel like I don't have a really good answer on why people would use the phase shift over the horizontal shift. Okay? So, this means we can take a look at any function and be able to say a few things about it. So can we try doing that? Say yes. All right. I'm going to grab the classwork, and we'll look at 27 first. All right. Whoops, that didn't work. Let's try that again. All right. So, without using a calculator, isn't it supposed to be there? Somehow it got all the way over there. All right, let's see. All right. We need to talk about the amplitude, the period, the midline, and the phase shift, not the horizontal shift. So here's an example of where we might actually have to talk about the phase shift. All right, so let's take a look at A. What can you tell me about y equals 150 cosine 60 pi t? Give me something. Rafi. There's the amplitude for you. Okay? Rafi calling someone to tell me something else. Yep. Calling someone else. No. 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 Going back to here. The phase shift is only if you have a plus or minus in the parentheses. So going back to this, do we have any plus or minus in the parentheses? No. So give me the phase shift. Awesome. Okay. Phase shift is 0. You actually took the hard one there. There's one left, and that's what the period is. And I need the wrong answer for the period. 60 pi is the wrong answer. I couldn't have asked for a better wrong answer. So what's the relationship here? Sam Snyder?
Is it 2 pi over?
2 pi over 60 pi. End of story. T is the variable, so that doesn't play into it. So 2 pi over 60 pi, and of course you can see that would reduce to just 1 over 30. So this has an amplitude of 150 and a period of 1 over 30. So if you had to draw that function, right, it goes up to 150 and down to negative 150, and it does all of that in 1/30th of a unit. Oh, yeah, what'd I do wrong? Yeah, it does. It's a cosine function. I drew a sine function. All right, so if you're to draw a second, that would be 2/30ths, right, or 1/15th. Okay? Let's jump to C. All right, Sam Snyder, call on someone. Oh my goodness. Call on someone to tell me something about this function. Travis got a hand up over here.
Travis. Is the midline 0?
Say it like it's not Jeopardy.
Midline 0.
Midline 0. Hey, just out of curiosity, in B, what's the midline here?
5.
3 or 5? Which one?
5.
Okay. All right. I was just checking. Because it's hard.
I'm quizzing you.
It's not hard. It's tricky when we, right, it's not in the order that we're used to seeing it. Okay. All right, back to C. Travis calling someone. No. No. So I'm going to go back. I'm going to go back. When it's in parentheses, we call that the horizontal shift. The phase shift is when we distribute and multiply those two together. So try again with the phase shift. No.
3 pi over 12.
Negative 3 pi.
It's actually 3 pi over 12. The phase shift is minus whatever, and the whatever is the phase shift. So 3 pi over 12, which we could say is the same as pi over 4. Travis, stop being annoying. All right. Phase shift is a little bit hard. I can see that. This is the second one. Oh, thank you. I definitely did. All right, Danny, who's up? Amplitude is 1. And I think the only thing else I have is period. What's the period here? Calling someone, Sam.
Oh, sorry.
You have Monty behind you. You have
2 pi over 2.
2 pi, not over t. 3. Okay? So whatever this value is in front, the coefficient of t. So when we multiply those together, it's 3 pi over that coefficient. Okay? Is that all right? You sure? All right, let's take a look. Yes, Evan.
So you know the sine function starts at the origin, but the cosine function, what is that like?
The sine function starts at the midline and goes up. It happens to be, when we haven't shifted it, it starts at the origin, but saying it starts at the midline covers more of your bases. You can say that the cosine starts at its maximum value, if that helps.
All right, thank you.
All right, let's try 28, which is a little harder. Oh, that didn't work. Try that one more time. All right, 28, find a possible equation for this graph. Give me some information that we can tell from this picture.
The
How can we find out? All right, let's do some hand raising and let's see what we have. All right, Elizabeth. At 8, so this is 1 comma 4, so that's 4, and then this is 12 comma, oh no, I did that wrong. 4 comma 1, right? And 12 comma 5. Alright, so the midline is 3. That's going to help us. Calling someone, Elizabeth.
The midline is 3.
It is.
And the amplitude is 9.
No. Corinne, you say that? Is that you? Who said 2? Corinne, awesome. Way to go. Tell us why. Alright, so the y value is down to 1, up to 5 from the midline. If the midline's 3, 3 plus 2, 3 minus 2. Okay? I think I did it too. I got started off on the wrong foot. I think we're mixing up our x and y coordinates here a little bit. Okay? So let's just make sure we recalibrate the y, 1, 3, 5. This is 4. This is 12, so that must be 8, 16, 20. Okay? All right, Corinne, calling someone to give me another piece. All right, so we can call this, so that, let's see. We have a choice. We can call it cosine. We can call it sine. We can call it negative cosine. We can call it negative sine. Any one of those functions is actually right, so we can call it cosine. I'm happy to do it. If we call it cosine, we're going to have to do something. We're going to have to shift it over. And there are many math students who don't like shifting it over. I think what we should do is I think we should call it cosine and talk about shifting it over. And then when we're finished, we could go back and say, you know what, you could have called it and not had to have shifted it. Okay, so let's call it cosine. All right, so y equals something cosine. The amplitude is 2. So 2 cosine something plus 3, because that's the midline. All right, good. Monty, calling someone. Not Travis, because he's already talked. Not Elizabeth. Come on, someone. Like Michelle's got her hand up, even though Monty can't see it. Call on Michelle. All right, so the period, it starts at the midline. My midline's really bad. You're saying like my midline should look more like that. So the period's 16. It takes 16 units for it to go back to where it started from. I agree. Okay. So if the period is 16, what's the value for b? 2 pi over 16, which some people might call pi over 8. So pi over 8 is going to go here, and then I'm going to do x minus my shift. Okay, so we need to think with 1 minute left. The cosine function would have looked like this. The cosine function starts at its maximum, right? So we can think about this as the regular cosine function. We need to shift to the right. How many units? I don't think 16. I need to shift the cosine function to the right 12 units. If I shift this function over, I get the function I want. So I have to shift cosine 12 units to the right. However, someone could have said, you know what? Instead of shifting 12 units to the right, you could have shifted 4 units to the left, plus 4, because that's where this function was right here. You could have, is that what I wanted to say? Yeah, you could have shifted it back this way. And they're both correct. And as a matter of fact, I'm ready for someone to say, yeah, but if you had called it something else, you wouldn't have had to do a shift at all. If you had called it, you're so very close. negative sign. If you had called it the negative sine function, that's what this is. It's the sine function opening down. So you wouldn't have had to worry about a shift at all. Now, it's not always going to be the case that you don't have to worry about a shift, but some students actually feel like if they can avoid the shift, they'd rather figure out what the function is. Gravity gets you every time. Hey, have a tremendous Tuesday. And I'm not going to see you tomorrow.